All right, see what happens. All right, so our prayer is about joy. It's a very short one-sentence prayer. People search relentlessly for a city of happiness, not realizing that it can only be found in a state of mind. So I read that as if we're looking for material things, that really the happiness is kind of inside. I kind of buy that. I think that's okay. Okay, so I don't think there's anything I need to talk about except for jumping right into pre-calculus. Let me just double check. No, it says we're jumping right into it. All right, so we're going to do it a little bit different this time. I kind of thought that the ribbons and cutouts wasn't as effective as I wanted it to be. But so I'm going to try it on the smartboard today, where I don't know. We'll see how it works. You guys got to let me know. So here we go. So I want to review where we are at. I'm missing a lot of people here. I'm missing like 4 people. No, 3 people. Oh, well, what can I say? All right, so stop me if you want me to repeat, okay? If you want me to repeat this, I am happy to do so. But we kind of discussed the 45, 45, 90 right triangle, and we kind of figured out if we know that the hypotenuse is 1, then we did the algebra here that told us that each side is radical 2 over 2. Now, does anybody need me to go over that algebra? We're all good with that. Okay, all right. I'm not seeing any hands, so everybody's okay? All right. All right. So then we took this triangle here, and basically we stuck it in a unit circle. So I took this triangle right here, and I stuck it into the unit circle right here. Same triangle, hypotenuse of 1, 45, 45, radical 2 over 2 one side, radical 2 over 2 the other side. And what that told me was that this point right here, which we said was a pi over 4 angle, that this point where it hits the unit circle, since I'm going radical 2 over 2x, and I'm going radical 2 over 2y, the coordinates of that point are radical 2 over 2, radical 2 over 2. Am I still going okay? Everybody following me? Speak up if you're not, please. We're good with that. Okay. Well, then what we did. Well, we're gonna just kind of do that over again a little bit, because this is where I went. I flipped to the cutouts, and it was okay, but I think I have a little bit better way to show you this here. So so what I'm going to do is I am going to, come on, shapes. I'm going to make a 45, 45 right triangle. This is a 45, 45 right triangle. And I'm gonna flip it the way that we want it right now. Come on, flip it left to right. Okay, that's good. Okay. And we know that because I told you, the hypotenuse is 1. This side is radical 2 over 2, and this side is radical 2 over 2. Everybody's still good with that? I'm hoping. Let's make that one little thing here. Control G. Okay. And now what I'm going to do is I am going to put that inside of a circle. Oh, this is lovely. That's pretty good. All right. And I'm going to make an X and a Y axis. I'll try to do that right here. Let me just straighten those out so that they are actually perfect, or relatively speaking, perfect. There we go. Okay, so so I now have my 45, 45, 90 right triangle inside the unit circle, and I think we're going to all agree that this point right here is the point radical 2 over 2, comma, radical 2 over 2. All right, so same thing we just did. Any questions so far? No questions. All right, so here's what we're going to do. We're going to do two things. First of all, this angle here is 0 to pi. We know that this is pi over 2. We know that this is pi, and we know that this is 3 pi over 2. And because this is halfway, we said that this is a pi over 4 angle. Okay, magic bulb, gotta get the magic bulb. So do I have agreement that a 45-degree angle is the same as a pi over 4 angle? Do I have agreement on that? I'm seeing yeses, okay. So if I go 45 degrees there, and then I go another 45 degrees, I know that you all know that that's a 90-degree angle, right? And so I had 1 pi over 4 angle, and then I added another pi over 4 angle. So that is 2 pi over 4, which you can see I can simplify to pi over 2. Is everybody okay with that? Okay. Well, now here's the magic, okay? Here's what I was trying to do the other day, and we'll try it again here. So I'm going to take our 45, 45 right triangle, and I'm going to flip it. Great. And I'm going to, well, come on, come back. Now I'm going to move it over here. It's still a 45, 45 right triangle, right? It hasn't changed. I mean, the numbers got all backwards, but you know, that we just have to live with that, I think, right? So if this was, I just made that like totally wrong. Come on, Glenn, get it together here, dude. There we go. If this was pi over 4, and this is 2 pi over 4, what's that angle? I'll take a volunteer. Come on. 1 pi over 4, 2 pi over 4, 3 pi over 4. This is a 3 pi over 4 angle. And if I go again, so I did 1 pi over 4, I got a 2 pi over 4, I got 3 pi over 4. What's it to down here?
4 pi over 4.
4 pi over 4, which amazingly enough, 4 pi over 4, doesn't that reduce into just pi? Are you following me here? Is everybody following me? We're good? Okay, great. Okay, now 3 pi over 4. We know what the sides are of this triangle because we calculated them like back here, and back here, and back here. We calculated all those. So I'm going to ask Jordan. Okay, Jordan, what are the coordinates of this point right here?
Square root of 2 over 2 and negative square root 2 over 2. Or never, yeah.
You're close, but this is the x value and this is the y value. So which one's negative and which one's positive over here in this quadrant?
The x value?
The x value is positive or negative?
Negative.
Yes. So it's negative radical 2 over 2, positive radical 2 over 2. Do you see it?
Yeah, yeah.
You good with that? Everybody good with that? Yes? Okay. Well, we kind of did that the last time, but let's do something else. Let's take our triangle now and let's flip it upside down. Now I'm going to move the triangle. No, stop. Come on, triangle. I'm moving it down here. Okay, so let's ask Mary Rose. Mary Rose, I had I had 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Yeah, what angle do you think this one is right here?
5 pi over 4.
If you take away the question mark, you'll be 100% correct.
5 pi over 4.
This is 5 pi over 4, right? All we're doing is we're taking this circle and we're just dividing it into pieces. This is 5 pi over 4. So if that's 5 pi over 4, let's ask Alex. Alex, same triangle, right? Triangle hasn't changed at all. So what are the coordinates of this point?
Is it negative square root 2 over 2 and negative square root 2 over 2?
Indeed it is. Right? It's the same square root of 2 over 2. We just now moved it into the quadrant 3. So I'm going to ask somebody a different question here. We're going to just mix it up a little bit. Mary Rose again. Mary Rose, I would like to know, this is a 5 pi over 4 angle. I want to know what is sine of 5 pi over 4, cosine of 5 pi over 4, and tangent of 5 pi over 4. Can you tell me?
The sine is negative 2 radical over 2.
Negative radical 2 over 2.
Yeah,
how do you know that? How do you know that?
Because it's the y value.
Because it's the y value right over here. Excellent. And what about cosine?
The same thing, negative 2 square root over 2.
And what about tangent?
1.
1, right? Divide sine by cosine, I get 1. How we doing? Questions? Not yet. Okay, very good. Okay, so let's ask somebody else one more question, different question here. Related but different. So Jordan and Mary Rose, the only people I'm calling on today. All right, so Jordan, what is, I have to move my 6-pack over. Hang on a second. I want to be proper here. So let's move this over to here for a minute. And I want to know, Jordan, what is cosecant pi over 4, secant pi over 4, and cotangent pi over 4? So what is cosecant pi over 4?
Sorry, I was on mute. It would be 1 over negative 2 square root 2.
Great. So what is that as not a 3-level fraction?
Sorry, I'm just doing the math right here.
Okay, go ahead.
Sorry, I'm just blanking out. I'm not exactly sure.
Okay, so if it's the reciprocal, right? You
Yeah.
know that it's 1 over this value, right? So with
Yeah.
the reciprocal, all we need to do is flip the numerator and the denominator.
Okay.
So -2 over radical 2.
Okay.
Do you see that?
Yeah.
Okay. What about secant then?
It would,
Go ahead.
oh, also me?
Yeah.
Would also be -2 over negative radical 2.
Well, now it's -2 over radical 2. You don't want to put negative on the top and the bottom. That would make it a positive.
Okay. Oh, sorry. Yeah, I looked at the one on top, and I thought the equal sign was a negative sign. It was just.
Okay.
Yeah.
And you know, it is only 8:17 in the morning, so you know, don't worry about it, right? All right. And so then, Jordan, what about cotangent pi over 4? Or 5 pi over 4? It should be 5 pi over 4. Sorry, my bad.
So that would be negative square root 2 over 2 over negative square root 2 over 2.
Which is?
Is that equal to 1, or am I just?
Yes, it is. Anything divided by itself is equal to 1. Yeah.
Okay.
Now it's 8. Now it's 18. It's becoming less acceptable now. You know, I mean, every minute we go along, you know, I expect people to be more there. You know, did you have your coffee this morning?
I did, but I'm just, you know, I'm kind of out of it.
Maybe we need another cup. No. Okay, right. All right. So everybody okay with that? Are we okay? Yes. Kristen, I can't see you. Are you okay? Are you there? Wake up. Come on. 8 o'clock in the morning. Let's go. Are you okay with this? Clark, I can't see you either. Are you good with this? All right, good. All right, so now we're going to do something else. You never guess what we're going to do. We're going to take the triangle again. You know what? I better get rid of all this green stuff first. So let's just kind of get rid of all that green stuff here. Get it out of the way. Okay, taking my triangle. Come on, triangle, let's go. And I'm going to flip it one more time. And now I'm going to move it. I don't know why it keeps doing that, but that's okay. Come on, triangle, where are you? Here we go, moving it over here. Same triangle. So Ariel, 2 questions for you. What is this angle that ends right here? What is this angle that goes all the way around to there? And give me a second, I gotta close the window. Okay, Ariel, what is that angle that goes all the way around to there?
7 pi over 4.
That is a 7 pi over 4 angle. And can you give me the coordinates of this point right here?
Yeah, the square root 2 over 2. And then negative square root 2 over 2.
Excellent. So can you give me sine 7 pi over 4, cosine 7 pi over 4, and tangent 7 pi over 4? I'm not going to ask you, Ariel. I'm going to go to the magic bowl. Kristen, can you give me those numbers?
Can you repeat it one more time?
Yes. Ariel told me that this point right here on the unit circle helps me make this angle, right? And that is a 7 pi over 4 angle. And she told me that the coordinates of this point are radical 2 over 2, because I'm going this way, radical 2 over 2, and negative radical 2 over 2, because I'm going that way, radical 2 over 2. X, and y, those are the coordinates of that point. So what I want you to give me is sine 7 pi over 4, cosine 7 pi over 4, and tangent 7 pi over 4.
Okay. Would the first one be radical 2 over 2?
A little bit louder.
Radical 2 over 2?
For the sine?
Yeah.
Sine is the y value.
A negative radical 2 over 2.
Negative radical 2 over 2. And what about cosine?
A positive.
That's the positive radical 2 over 2. And what about tangent?
Negative 1.
Indeed. There you go. All right. That's good. All right. So this is how we put together the unit circle with our pi over 4 angles. And just to kind of explain the angles one other way here, I'm going to make a circle, and I'm just going to draw my my axes in here. Here's my x, and here's my y, and we know, because over and over we've said it, this is angle 0 and angle 2 pi, and also if all the way around is 2 pi, then halfway around is pi. And then halfway to halfway is pi over 2. And down here at the bottom is 3 pi over 2. So now, again, listen carefully, because this is going to give you like another way to understand where the angles are on the unit circle. And it'll be very helpful for the next segment that we're going to do, which is pi over 6 and pi over 3 angles. Okay, we're going to have a party, okay? And the party is Alex, Isabella A, Brooklyn, and Sydney, okay? Alex, Isabella A, Brooklyn, and Sydney. How many people do I have there? I got four people there, right? And I ordered a pizza, okay? But they only sent me half a pizza pie. You get it? Half a pizza pie. They only sent me half a pizza, but they only sent me that much. Okay? And I have to divide it equally between them. So I need to have my pie divided into 4 slices. You know, let's just make it really totally clear here. I don't want anybody to get confused. Solid fill, white, and line style, white. Okay, so like I said, they only sent me half of a pie, so that's what they sent me right there. Okay, and so does everybody agree that I divided this pie up into 4 relatively equal pieces? Yes. So then, isn't this piece right there pi over 4, right? And then there's another pi over 4, so this would be 2 pi over 4, which I can simplify into pi over 2, and then 3 pi over 4, and then 4 pi over 4, right? So that's how I know where all these points are. And if I just kind of continue down around the bottom, well, then I know that this right here is 5 pi over 4. This is 6 pi over 4, which simplifies into 3 pi over 2. This is 7 pi over 4. And this is 8 pi over 4, which simplifies into 2 pi. So all I'm doing is I'm just taking pi and I'm just dividing it into 4 pieces on the top and then on the bottom. And that gives me all my angles. How we doing? We doing okay? We're doing all right. Okay. Brooklyn, we doing okay? Your brow is furrowed. No, you're good?
Actually, I guess I do have one question.
One more, yes, please, louder.
So it says 0, 2 pi. What's the 0 for?
So now you're clear that these are all angles, right?
Yeah.
Okay, so if I start with my initial side, which is always from the origin and then the x-axis this way here, right? And then I don't move at all from my terminal side. I don't move at all from my terminal side. How far have I gone?
Nowhere, 0.
I've gone 0. That's why it's 0. So that is at angle 0. And if I go all the way around and come back to the same spot, well, it's not 0 anymore because I've gone all the way around. I've gone 2 pi. It's the same thing as, and I hate to do this, but I'm going to, 0 degrees and 360 degrees. I think you would understand that, right? So it's 0 radians, just like it's 0 degrees, and it's 2 pi radians, just like it was 360 degrees. Good? Everybody good? Okay, super. So, we're going to take a little bit of a tangent, and we're gonna do a couple of problems here. Right? Now, this is a page that you need to print out and show your parents, and you need to, because you're going to say to your parents, you say, "Can you do this?" And they're going to say, "I can't do that." You say, "Oh, I can do that." "You can't do this?" "I can do that." Right? So this is giving you a little bit of an edge on your parents here. Right? Because this looks very intimidating, right? But it is not intimidating. Do not be intimidated. We're going to make this like totally clear. How many people think this looks intimidating? Some people only, okay, so nobody's really terribly intimidated. All right, so look. When I have f of x, does anybody remember what do we call this part of that? There's a word for it. And it's not x. What is that? What is that? What is the word? Yeah, Mia, what?
We called it the argument or the input value.
Yes, this is the argument of a function. If I just write f, that means nothing, right? If it has an argument, then it's, oh, this is a function. Okay. All of the trigonometric functions are functions. So the only place I'm allowed to write sin is in religion class. I'm not allowed to write that in math, right? Sine has to have an argument. And the argument is an angle. The argument of all trigonometric functions are angles. And what you get from that is a number. Right? So back here, when we were doing like sine 7 pi over 4, the 7 pi over 4 is an angle, and the negative radical 2 over 2 is a number. Okay, so the sine function has an argument that's an angle, and the answer is a number. So if I'm looking at this problem right here, which is in degrees, but we'll live with it, you know, painfully, but we'll live with it. This right here, sine 180 degrees, this is a function with an argument. It's a number. And cosine 45 degrees is a function with an argument. It's a number. Okay. So thinking about our unit circle, and we'll make it into degrees against my better judgment, but we'll do it. So this is 0, 360. This is 90 degrees. This is 180 degrees. This is 270 degrees. Okay. Magic Bowl is asking, Ariel, what are the coordinates of this point right here?
-1, 0.
Excellent. Okay, -1, 0. So Ariel, what is sine 180 degrees?
0.
Yeah, so sine 180 degrees is 0. All right, now let's ask Isabella A. Isabella, cosine 45 degrees. So 45 degrees is right here, or close enough. What are the coordinates of this point?
Would it be 1, 0?
Nope, 1, 0 is going to be over here. Remember, this is our triangle here, and I have a 45.
Oh.
Yeah.
Oh, would it be I forgot. Radical 2 over 2, comma radical 2 over 2.
Radical 2 over 2, radical 2 over 2, right? You with it? You got that?
Yeah.
So cosine 45 degrees is radical 2 over 2. So they're telling me multiply sine 180 degrees times cosine 45 degrees. So 0 times radical 2 over 2, well, that's 0, right? Yes. It's just one number times another number. That's all it is. Just one number times another number. Now this one here, a little bit more complicated, because this one here, I have sine pi over 4 times cosine pi minus sine 3 pi over 2. Okay, so let's actually redraw our unit circle here. Whoops, no. Come on, over here, this way. Stop. There we go. So I'm going to redraw a unit circle, which is always a good place to start with these problems. And I have 0, 2 pi, pi over 2, pi, 3 pi over 2. And my first question here is, well, what is sine pi over 4? So here's pi over 4. There's our pi over 4 angle. I'll mark it pi over 4. And we're asking, I'm calling on the same people here. I mean, I know the probability is low with a class this size, but it doesn't matter. Kristen, what are the coordinates of pi over 4?
I'm not sure.
I can't hear you.
I'm not sure.
Okay, so here I gave you see this picture here?
Yeah.
And here's a pi over 4 angle, right here.
Yeah, oh, so it's just radical 2 over 2.
So what are the coordinates?
Radical 2 over 2.
Radical 2 over 2, radical 2 over 2. So Kristen, what is sine pi over 4?
Radical 2 over 2.
Radical 2 over 2. Okay. Let's go here to, we need to get mix it up here a little bit here. Huh? Let's see. Oh, okay, Sydney. Sydney, here is pi. Here's cosine, here's pi. What are the coordinates of that point right there, Sydney?
Would it be -1, 0?
Yes, that's exactly what it would be. So what is cosine of pi?
-1, 0.
Well, no, it's just one value. Just value. Which one is it? The x value or the y value for cosine?
What? Is it the y value?
No, it's the other one.
X, yeah.
All right. So cosine is x. So what is cosine pi?
The negative 1, 0.
No, no, no. Not
Negative
the, just the x value. Yeah, just negative 1. Are you okay with that? Okay, okay, so cosine pi is negative 1. And then we want Brooklyn. So 3 pi over 2 is down here. What are the coordinates of this point?
Is that square root of 2 over 2?
No.
I mean,
Square root. This is right on the axis. This is a quadrantal angle.
yeah. 0, comma, negative 1.
Very good. 0, negative 1, right? I haven't gone anywhere on my x-axis, but I've got negative 1 on my y-axis. So what is sine 3 pi over 2?
Negative 1.
Very good. Negative 1. All right. So now I need to do this calculation. I have radical 2 over 2 times negative 1 minus negative 1. Oh, that means plus 1, right? So let's make that. So let's go radical 2 over 2 times negative 1 plus 1. So multiplication before addition, right? You have to do our order of operations. So I have negative radical 2 over 2 plus 1, and that's my answer. This whole big ugly thing here is this number. I've just taken a few numbers and I've added them together, multiplied them and added them together.
So Mr. Jenkins, you multiplied radical 2 over 2 times negative 1 and then subtracted a negative 1.
That's right.
Okay.
You see it? Okay, right. Yeah, so you have to be careful with order of operations, multiplication before subtraction. Okay, so now we're going to go to one that is a little bit harder, but actually will have a very practical use. Somebody remind me to tell you what the very practical use of this one is. All right, so can I erase this on the bottom here? Is that okay? Everybody okay with that? I can erase it now? Yes, okay, I'm going to do it then. All right. So I'm going to make a unit circle. And I'm going to do over here a 6-pack. Sine theta, cosine theta, tangent theta, cosecant theta, secant theta, cotangent theta. All right, here's my unit circle. 0, 2 pi, pi over 2, pi, 3 pi over 2, got it. Sydney, this is taped. So you can kind of pick up, I don't know, 45 minutes into the tape, and then you'll have the rest of it, okay? Good. All right. So I need to find out cosecant pi over 4. Oh, no. And then I have to square it. Oh. Will they never cease? Will they not give me rest? So here's pi over 4. Let's see. Mary Rose, coordinates of pi over 4.
Square root of 2 over 2, square root of 2 over 2.
Square root of 2, square root of 2 over 2. So I'm taking this in the steps that I would use to do this. So what is Brooklyn? What is sine of pi over 4?
Radical 2 over 2.
Very good. Sine of pi over 4 is radical 2 over 2. So sine pi over 4 is radical 2 over 2. What is cosecant pi over 4?
I don't really understand how to do the cosecant or like this
Okay.
part of it.
Okay, so these three, I call them our main trigonometric functions. And these three over here are our reciprocal trigonometric functions. So then the reason I like the 6-pack is because this is telling me cosecant is the reciprocal of sine. And reciprocal basically means flip it over. Instead of, it just take the numerator and the denominator and flip them. So what is the reciprocal of radical 2 over 2?
2 over radical 2.
That's right. It's 2 over radical 2. So now I know what cosecant pi over 4 is. So I know that this is 2 over radical 2 squared. So let's ask, let's see, who do we got going on here? We got Isabella C. What is cosine of pi over 4?
Is it just Is it just radical 2, or I mean, what's it called? Radical 2 over 2.
Yep, that's what cosine is. Cosine is the x value, sine is the y value. So Isabella C, what is the tangent of pi over 4?
It would be 1.
It would be 1. Very good. Oh, so I've got the tangent of pi over 4, which is 1. All right, so I'm making some progress here. So I've got my trigonometric functions. I've turned them into numbers. And now I'm just going to do some math with them. So I have 2 over radical 2, but I have to square it. So that's the same thing as 2 over radical 2 times 2 over radical 2, which is, Alex, what is that?
Is it 4 over radical 4?
Well, you could say 4 over radical 4. And what is radical 4? Simplify radical 4 for me.
2.
4, and what's 4 divided by 2?
2.
Ah, very good. So this number right here is 2. And I'm adding 1. Well, so what is 2 plus 1?
Oh, 3.
2 plus 1, 3.
No,
Right? I was asking anybody. 2 plus 1 is 3, right? So this whole big ugly thing right here, which isn't really that ugly, it's really rather beautiful, it's 3. So practically speaking, who has like very young nieces or nephews? Okay. Isabella, how old? Oh, Isabella A, I was asking, how old is your young niece or nephew?
Oh, sorry. She just turned 2.
She just turned 2. So for her next birthday, on her birthday cake, this is what you're going to write. You're going to write that, right? Because she'll be 3. Okay, will you do that?
I'll try.
Nah, you probably won't do that. I have to show you. I have to show you my mom's birthday cake. Okay, my mom's birthday cake. I may have shown some of you this before, but let's see here. Let's go for cake. C-A-K-E. Mom's limit birthday cake. Here we go. This is the birthday cake that I gave my mom when she turned 90. Yeah, it's the limit as x approaches 3 of 10x squared, which is equal to 90. Yeah, so see, that's fun stuff you can do. You do this with your little kids, you know, and then they're going to say, what's that mean? And then you never know, they'll become mathematicians or something like that. So, okay, are we relatively comfortable with these problems? The thing to remember is that a trigonometric function gives you a number, right? So it just looks mystical, but it is not mystical at all. It's just a number. I feel like a number. Bob Seger. That was our song last week. I feel like a number. Yes. Could have been talking about this.
Sorry, Mr. Jenkins, can you check your private chat really quick?
Yes, yes, yes. If it lets me, hang on a second. Sometimes it lets me, sometimes it doesn't. Yeah, it's fine. Yeah, let me make a comment in general. If you have to go to a college, it is always okay to go to a college meeting. I mean, unless you're having a test, it's good that you tell me, right? But if we're doing something that's just like regular class, just go right ahead. You know, let me know, but get your notes and you're cool. That's great. But thank you. Yeah, go ahead, have fun. What college is it? Oh, too late. Too late. All right. So we're relatively comfortable with this, yes? Okay, but in order to get completely comfortable with this, what do we have to do?
Practice problems.
Thank you very much. Practice problems, practice problems. That's what's going to get you completely comfortable with this. All right. So we're going to push on a little bit. And we're going to talk about the exact values of trigonometric functions of pi over 6 angles and pi over 3 angles, right? So we are going to ignore this for the moment. No, we'll do it my way here. All right, so, you know what? We're going to mix it up a little bit. I'm going back to the whiteboard here. Let's mix it up a little bit. So, okay, everybody should be in speaker mode. You should be in speaker mode anyways. And let's see if I can't, wrong, yeah, that's right. Up, 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 up. There we go, pretty good, all right. Chair, out of the way. Triangle, everybody see the triangle? Yes, okay. 30 degrees, 90 degrees, 60 degrees. 30, 60, 90 right triangle. And I am telling you that the hypotenuse is equal to 1. So I would like to know, this is my x value, this is my y value. Let's call this A, let's call this B. What do you think I'm going to use to find out A and B? Anybody can answer.
The Pythagorean Theorem. I can't say it, sorry, but
Pythagorean Theorem.
yeah.
So A squared plus B squared equals C squared, right? That's what we used before the other one, right? But the other one was kind of cool because the other one, A and B were equal. Now A and B are not equal. So actually, the Pythagorean Theorem, not going to help us. Bummer. But it was the right answer. That was the right answer, but it's the wrong answer, right? So we're going to do a little trick here. Now, again, I am telling you right now, this is on the test, okay? You are going to have to do exactly what I'm doing on the test in exactly the way that I'm doing it here, right? So we're going to take our 30, 60, 90 right triangle. And what we're going to do is we're going to flip it over. We're going to make it identical and we're going to flip it and we're going to have, it's going to look like this. So I've taken this triangle here and I've extended it by flipping it over. Is everybody okay with that? Okay. Well, so now if I flipped it over, Maria, how many degrees is this angle right here? Now I have this much larger big triangle. How many degrees is this angle right there?
That's 60?
That is a 60-degree angle. And Maria, how many degrees is this angle down here?
30?
No,
9?
no. Now I'm looking at this big triangle right now.
Is it also 60?
It is also 60, right? I mean, you know that from two ways. One is I took this triangle and I flipped it over, so this angle kind of stays right there. You see it, right? But also, 60 plus 60 would be 120, and if there's 180 degrees in a triangle, that leaves 60, so that's 60 down here. So I have 60, 60, 60, which is known as a what kind of a triangle? Isabella C., do you remember?
I do not remember.
That's okay, you don't have to remember. Does anybody remember what kind of a triangle this is? Yeah, okay, Crystal, what?
Is it an equilateral?
It is an equilateral triangle, right? All the angles are the same, and actually, I don't know if you're aware of this, but the word lateral, L-A-T-E-R-A-L, that means side. So equilateral means that all the sides are equal. Makes sense, right? So if the hypotenuse is 1, let's change colors. That means that this side here is 1, and it means that this side here is also 1. I'm going to pause right here and make sure everybody follows and understands what I just did. Is that everybody good with that? Right? Took the original triangle, flipped it over, became this nice equilateral triangle. All the sides are 1. Okay. Now, if all the sides of this triangle are 1, then how big is just this piece of our original triangle? Magic Bowl is asking Maria.
It's like half? It's half?
Yeah, this is a half, right? I mean, I flipped it over, right? So if the whole thing is 1, then this side is a half. Are we okay with this? This is like awesome, right? Now, Jordan, I was wrong. We do need the Pythagorean Theorem. We do, because now we got two sides. I have side B and I have C. So I'm going to come down over here, right? And I'm going to write, well, a squared plus 1/2 squared is equal to 1 squared. I took my side B, and now I have a number for it, so I can use it in the Pythagorean Theorem. A squared plus 1/4 equals 1. Let's subtract 1/4 from both sides and go a squared equals 3/4. Now we take the square root of both sides, and I have a is equal to radical 3 over radical 4, which is radical 3 over 2. This side is radical 3 over 2. Whoops, I'm in the way. There we go, that's better. Could you do this? Yes? No? Could you do it after watching this video a couple of times? Yeah, and there's the same video is also already on the video index. I'll put this one on there as well, right? But I'll send this out. So this is the method that you need to use to show me that you know how to calculate the sides of a 30, 60, 90 right triangle. Are we still doing okay? Okay, so we're going to do something. We're going to go, I'm going to share the screen again. I'll probably make my head a little bit less big. Yeah, that's better. Let's share the screen. And I'm going to do something here. Wait a second here. I'm going to, I want to take a picture of that so that we have it. Okay. And then I need to share that with me. Okay. We'll get that up later. Okay. Let's make a new shape. I hope that's not too big, but we'll try it. Okay, and let's flip it. So that is a 30, 60, 90 right triangle. And my hypotenuse is 1. Maria again. Maria, if my hypotenuse is 1, how long is this side, the short side?
Half?
Louder.
Half?
It's a half. Why are you so tentative about it? You just calculated it for me over there. Don't be tentative. You can do it. You got it. All right? And, oh, Juji is not here. Her Wi-Fi was out. All right. So Clark, are you here? You're here, Clark. Clark, how big is this side right here?
Radical 3 over 2.
This side here is radical 3 over 2. So let's make this like one solid thing right here so that it doesn't change. Right? Now just for clarity here, if I make this triangle like really big, do those still hold? Anything change in the numbers? No, because the hypotenuse is still 1. Maybe it's 1 mile instead of 1 foot. Or if I make it really, really tiny, does it change? No, the ratios are still going to be the same. So I'm going to have it, I'll have it that big right there. And now I'm going to make a circle. And I'll start the circle right there at the vertex. And it's going to fit like that. And I got to make my X and Y axes again. Oh, that one came out pretty close, didn't it? That one's kind of far away, but that's okay. We can fix it. That's pretty good. And let's just make this one just a tiny bit higher. There we go. Okay. Now I want to do something else first. Okay, we got this in the circle here. Well, I'm going to do something else first. How are we doing time-wise? We're doing okay. Are you guys hanging in there okay? Yeah, we're doing all right? Not too brain dead? No, not yet? All right, good. All right, good. So I'm going to do one other thing here. I want to do a little bit differently. I want to make a circle. And I think I'll put my X and Y axes in here. I think the Y looks pretty good, but I think the X looks a little bit too high. Maybe about there. Okay, that looks good. All right. So 0, comma 2 pi, pi over 2, pi, 3 pi over 2. I want to have another party, right? I want to, this time I want to have more people at my party. So I'm going to have Alex, Mary Rose, Maria, the 2 Isabellas, and Mia. So how many people is that? Alex, Mary Rose, Maria, the 2 Isabellas, and Mia. How many people is that? I got 6 people there, right? And again, I ordered this pizza from, I guess I'm going to call this place Half Pie Pizza. Yeah, that's what we're going to call it. Half Pie Pizza. And they send me that, right? And I want to divide it up into 6 pieces. So I'm going to divide it up into 6 pieces right here. Here's, they're pretty close. 3, 4, 5, 6. And pretend, okay? They're pretty close, you know. 6 pieces, yes? So from here to here is pi. How big is this slice right here? And we're asking, Sydney's stepped out to go to a college meeting. Brooklyn went too, so our 2 college meeting people went out. That's a 2 out of 14 chance. Okay, Isabella A, how big is this piece right there?
Would it be? It wouldn't be pi over 4, would it?
It wouldn't be pi over 4 because I divided it into 6 pieces instead of 4 pieces. So what do you think it's going to be?
I'm not sure.
Okay, so I'm gonna push you on it a little bit here. Before we had our pizza, right? And we divided it into 4 pieces, right? This was pi and this was 0. And so each piece was pi over 4, right? 1 pi over 4, 2 pi over 4, 3 pi over 4, and then 4 pi over 4. Are you okay with that?
Yeah, so then would it be pi over 6 then?
That's exactly what it would be. Excellent. This is a pi over 6. Pi over 6, right? We divided it into 6 pieces. So everybody has a piece at the party, and now that's pi over 6. So then, Mia, if that's 1 pi over 6, what is it when I go to here?
2 pi over 6.
It's 2 pi over 6, which just for instance, I can simplify into pi over 3, can't I? Right, 2 over 6, same as 1 over 3. Okay, Mia, again, I go over to here. How many pi over 6s is that?
3 pi over 6.
Yeah, oh, and what do you know? 3 pi over 6, that simplifies into pi over 2, doesn't it? Yeah, okay, we're rocking here. Let's ask Crystal. I got here to 3 pi over 6. What am I at when I go to here?
4 pi over 6?
I'm at 4 pi over 6. And can I simplify that?
Yeah, so it would be 2 pi over 3.
Yes, it would. And Crystal, I want to go now to here. What am I there?
5 pi over 6.
I'm 5 pi over 6, which I can't simplify. But then I go down to here. And what's that?
6 pi over 6, which is just pi.
Which I can simplify to pi. Right? So now I've divided my pi into pi over 6s. So we're going to ask another question here. Oh, Crystal again. All right, Crystal, in degrees, how many degrees is that angle right there?
180.
That is 180 degrees, right?
Mm-hmm.
And I divided the 180 degrees into 6 equal pieces, right?
Yeah.
Yeah, so what's 180 divided by 6?
30.
How about that? 180 divided by 6 is 30 degrees. So when I drop my perpendicular right down here, how many degrees are going to be in that angle?
60.
Yeah, so I have a 30, 60, 90 right triangle, don't I?
Yeah.
Everybody with me here? 30, 60, 90? And my hypotenuse is 1 because I told you it was a unit circle. Hypotenuse is 1. So let me just see if I can get this thing right here. Come on, download that. Open it up. Copy it. And let's put it in right here. Paste it. There we go. Okay, so we did this whole thing with a 30, 60, 90 right triangle, and I am back to here. So, so Mary Rose, how long is this side of this 30, 60, 90 right triangle? This is the long side.
Radical 3 over 2.
Radical 3 over 2. And Mary Rose, how long is this side of that triangle?
1/2.
1/2. Okay, then we're going to ask Ariel. Ariel, what are the coordinates of this point right here at my pi over 6 angle?
Radical 3 over 2 and 1/2.
Yeah, you're all over this, Ariel. Good job. Those are the coordinates of that point right there. And I think we're going to call it a day. All right, we can go a little bit further, but I think probably better just to kind of give you a little bit more. There's a lot of stuff you got here today. Yeah. So let me ask you a question though. Did we like the smartboard, like flipping the triangle, or did we like the whiteboard with the cardboard, with the cutout?
The smart board.
So how many people like the smartboard better? That was more clear? Okay. Alex, you're kind of indifferent, huh? Okay. Kristen, you like the smartboard too? Yeah? Okay. All right. So I think today, I think they said community time is like kind of chill time. It's nothing happening, right? Today's, yeah. So nothing happening. So just kind of go relax, maybe make your little poster for Sister Joanne, and I'll get this video posted so that you can kind of see it. All right? Adios.
Thank you.
See you later.
Thank you.
Thank you.
You're welcome.